Eagle, we got you now. It's looking good, over. Roger, copy. Eagle, Houston, after you're around.
What was one small step for Neil Armstrong was a giant leap from his beginnings at Purdue University. Students at Purdue all have a chance to follow in the footsteps of former Purdue students and Apollo astronauts Neil Armstrong and Gene Cernan.
Hello and welcome to the high pressure lab at the Maurice J. Zucrow Laboratories at Purdue, and I'll be showing you some of our rocket test capabilities. So here we are at the rocket test cell. Over here on my left you'll see the 10,000 pound thrust stand at Purdue. It has the capability to flow RP1, which is rocket propellant 1, gaseous hydrogen, and liquid oxygen. We can flow cooling water at about 110 gallons in 6 seconds, which is about enough to fill a swimming pool in 6 or 7 minutes. And the temperatures that the rocket engine sees range from minus 290 degrees Fahrenheit to flame temperatures of 6,000 degrees, which is about half the temperature of the surface of the sun.
So this is our control room. This is where we remotely control and monitor all the experiments through the 3 TVs here in the front. From here, everything is remotely controlled as well through a series of computer programs. All of this is student developed, student generated. The students modify it on a per test basis. It helps them understand how the actual system operates. So we're going to a test here. So a 3, 2, 1, 0.
Okay, so my experiment is the NASA COIP hydrogen-oxygen multi-element experiment. So we're taking liquid oxygen and hydrogen and forcing it through 7 fuel injector elements inside the combustion chamber, which is really useful to people who are designing rocket engines, and it's a sort of study that hasn't really been done before. We're really lucky to be able to do it at Purdue with a stand this big. It's important because we're doing the fundamental science on the types of engines that are going to form the next generation of engines that will take people to the moon and to Mars and get us where we need to go in space.
High-speed computing has enabled us to analyze and design rocket engine parts by use of computer simulations. The advent of high-speed computing has led to better understanding of combustion and stability, leading to improved engine designs and contributing to a reduction in the number of costly ground tests required to achieve stability.
Hi, I'm working on combustion instability in rocket engine. When a rocket engine experiences high-frequency combustion instability, it will make a high-pitched screeching noise. When you don't do anything about it, the engine might blow up and cause space mission to fail. My job is to understand what caused the instability and find ways to avoid it.
So as part of my research, I take what they're doing out at the lab and try and do something similar on the computer. So this entails using computer programming and coding to try and simulate what's going on inside the rocket. When the results do match the experiment, then it's very exciting because that means that we're getting closer to actually simulating the real physics of the rocket. One of the other perks is that I get to use the NASA supercomputer, which is equivalent to having 14,000 desktop computers. I really enjoy working for NASA and here at Purdue. It's a great school.
At Purdue University, we are using the lessons from the past to prepare for the future through the development of new and exciting technologies. It is with these technologies that scientists and engineers will develop the next generation of spacecraft to go to the Moon, Mars, and beyond. From Purdue University, this is Alex Sandroni, signing off.